Welcome to While We Were Distracted, the podcast where we explore topics that often get overshadowed in the rush of daily life. Please take a moment to like and subscribe, it really helps.
This is where we sift through a pile of research and pull out the essentials for you. Today we're tackling, well, one of the biggest topics out there, the current state of cancer research, our mission, to look beyond that persistent cultural idea of a single miracle cure. Instead, we want to focus on the real, personalized breakthroughs happening around 2025. And crucially, prevention.
Yeah, and it's so important to set the stage correctly here. You know, the public often hears about this hunt for the cure as if it's just hiding somewhere. But the reality, it's just much more complex and, frankly, much more successful than that narrative suggests. I mean, look, there isn't one single universal cure yet, no. But the progress, it's undeniable. Think about it. Overall cancer survival rates, say, in the UK, they basically doubled since the 1970s. Doubled.
It's a huge metric, a doubling of survival. Okay, so if progress is that significant, let's get right to it. Why is that universal cure, that single magic bullet, still seen as scientifically, well, maybe impossible? What's the fundamental barrier?
It really comes down to the definition, the word cancer. It's not one thing, it's an umbrella term. We're talking over 200 distinct diseases under that umbrella. So a single magic bullet. Scientifically, it's incredibly unlikely because these diseases, they vary so much. Genetics, where they start in the body, how they respond to treatment. You'd need like 200 different keys for 200 different locks at a minimum.
Okay, so it's not just the sheer number of types. It sounds like it's also about the resilience, the adaptability of the cancer cells themselves.
Precisely. That's a huge part of it. We're not fighting something static. Even inside one single tumor, you've got what we call genetic heterogeneity. Not all the cells are identical clones. So a treatment might wipe out, say, 99% of them, but that remaining 1%, they're slightly different. Maybe they have mutations that let them survive that specific drug,
Right.
and that 1% then grows back, and now you have a new tumor, essentially, that's already resistant to the first treatment. It leads to recurrence. Plus, cancer cells are constantly picking up new mutations. They evolve, sometimes really fast, faster than we can often switch treatments. It's like Darwinian evolution on hyperdrive.
Wow, that constant evolution.
Yeah.
And then leading to metastasis, right, the spread. That must be the ultimate challenge. Does it mean that for some really aggressive types, even finding it early might still be too late?
It absolutely can. The specific type of cancer and the timing, the stage, they dictate almost everything. Take thyroid cancer, for example. The most common kind, papillary. If you catch it early, the 5-year survival rate is fantastic, around 98%.
Okay.
But then you have the rare anaplastic type. It's incredibly aggressive. And its 5-year survival rate, it's agonizingly low, maybe 8%. It just shows the massive difference between managing a slow-growing disease and fighting a really aggressive one.
So that complexity, the 200-plus diseases, the evolution,
Yeah.
it really means the idea of one simple pill is, well, it's outdated. Instead, the 2025 arsenal, it sounds like it's all about personalized, targeted attacks.
Yeah.
Let's dive into those. What are the breakthroughs looking like right now? What's really leading the way?
Undoubtedly, the big revolution is in immunotherapy. Basically, teaching the patient's own immune system to recognize and kill the tumor. We're seeing really promising clinical trials now for personalized mRNA vaccines.
Like the COVID vaccine.
Similar technology, yeah, but personalized. They're designed using the unique genetic signature of a patient's actual tumor. The goal is to prevent the cancer from coming back after surgery, basically training the immune system to remember and hunt down any remaining cancer cells.
And that builds on things like CRT cell therapy, doesn't it? Where you take out immune cells, engineer them, put them back in.
Exactly. And the next step, the refinement there, is developing what they're calling smart CAR T cells. These are engineered with a more sophisticated kind of on-off switch or a call-in response function. It means they're designed to become less active or even degrade when they move away from the tumor site.
So they're more focused.
Much more focused, more precise, and hopefully safer by reducing those body-wide side effects of the toxicity.
That precision seems absolutely crucial. What other ways are we seeing researchers kind of supercharge a patient's own immune system?
Well, there are two other major strategies gaining traction. One is TIL therapy. That stands for tumor-infiltrating lymphocyte therapy. With TILs, you actually harvest the immune cells that have already found their way into the tumor. These are cells that already recognize the cancer, in a way.
Okay.
Then you grow them in the lab to massive numbers, billions of them, and then infuse them back into the patient. The idea is to overwhelm the tumor with these specifically targeted immune cells. It's very personalized warfare.
And you mentioned antibodies earlier, too.
Yes, another exciting area. Look at the recent approval of a new bispecific antibody for multiple myeloma. Bispecific means it can bind to two different things at once. In this case, it acts like a molecular handcuff. It physically links one of the patient's immune cells directly to a cancer cell.
Forcing them together.
Exactly. Forcing the fighter cell right next to its target, maximizing the chance of an effective immune attack.
Okay, so beyond boosting the immune system, what about targeting the cancer at its root, like at the genetic level that makes a cancer?
Yeah, that's the other major front. And we've finally seen real progress against a notoriously difficult target, the mutated RES gene. This gene, when mutated, is a driver in, well, a lot of cancers, maybe over 10% of all cases, possibly more. It's been very hard to drug. But now, compounds designed to specifically block the mutated form of RES are actually entering human clinical trials. That's a big step. We're also seeing very specialized approaches for really tough cancers like glioblastoma, the brain cancer. There's a new agent called a fusion superkine, or FSK, being studied. It tries to combine multiple therapeutic actions into one molecule.
And this is where it gets really powerful, right? The combination therapies, using multiple drugs together, showing synergy, turning really difficult diagnoses around.
That is the core of modern oncology, yes. Take that example of stage 4 anaplastic thyroid cancer with a specific mutation, the BRAF V600E1. The outlook used to be incredibly grim, just awful. But now, a triple combination therapy using pembrolizumab, dabrafenib, and trametinib, or DTP, it attacks different cancer growth pathways all at once. And in a recent trial, it led to no residual cancer being found in about 2/3 of patients before they even had surgery.
Wow, 2/3.
Yeah. Dramatically improving 2-year survival rates. The key takeaway isn't necessarily the drug names, it's the strategy. Hitting the cancer from multiple angles simultaneously, cutting off its escape routes.
That makes sense. And just quickly, there was also something innovative in radiotherapy delivery.
Right, flash radiotherapy. It's still experimental, but the idea is to deliver a very high dose of radiation extremely quickly, like in a fraction of a second. The hope is that this ultra-fast delivery might spare more healthy tissue around the tumor. If it works, it could potentially make radiation safer for treating larger areas, maybe even complex metastatic disease.
Okay, so these leaps in personalized medicine, the vaccines, the smart cells, the combos, they're truly astounding. But they are also incredibly complex, often very expensive, and fundamentally, they're reactive. They treat cancer once it's there. If we pull back to the bigger picture, the data seems overwhelming that the real miracle, at least on a population level, isn't finding a cure for every individual case, but preventing it in the first place.
That's exactly right. Knowledge is, well, it's only powerful if we use it. Treating advanced cancer when it happens is amazing. It's life-saving. But prevention. Prevention is the only strategy that can really slash the number of people getting cancer and dying from it across the whole population. Current research suggests at least half, maybe more. Some estimates go up to 70% of all cancer cases could potentially be prevented just by applying the knowledge we already have.
And we know prevention works, especially secondary prevention, meaning catching it super early. When you look at the cancers with the best recovery rates, if detected early, the survival numbers are almost hard to believe.
They really are.
Yeah.
You mentioned thyroid cancer earlier, but also prostate cancer, if caught early, around 99% 5-year survival. Early stage breast cancer, same thing, 99% to 100%. Melanoma skin cancer, 94%. Testicular cancer, over 95%. Those aren't just numbers, they're proof that screening, early detection, they save lives. Dramatically.
But let's be real for a second. Those high survival rates are fantastic news, obviously. But they sometimes mask the fact that treatment itself, surgery, chemo, radiation, can be incredibly grueling, long-term quality of life issues, right? Is there a risk we celebrate the survival stats without fully acknowledging the toll treatment takes?
That's a really critical point. A 5-year survival number doesn't tell you about the patient's journey, the side effects, the long-term impacts.
Okay.
And that's precisely why primary prevention, stopping cancer before it even starts, has to be the ultimate goal. Think historically. What drove down U.S. cancer death rate significantly over the last few decades? It wasn't primarily a new wonder drug.
It was smoking cessation, wasn't it?
Exactly. The massive decrease in smoking rates, that was a monumental public health victory, pure and simple.
But now, that victory seems like it might be threatened. There's a looming issue that could actually reverse that downward trend in cancer deaths. obesity.
It is, unfortunately, the next major crisis in cancer causation. Obesity is now a well-established risk factor for at least 13 different types of cancer. And for some, like endometrial cancer, it's thought to be responsible for maybe up to 60% of all cases. It's a huge driver. So when we talk about actionable primary prevention, the things individuals and societies can do what works, lifestyle changes make a massive difference. Quitting smoking, maintaining a healthy weight or BMI, getting regular exercise, avoiding heavy alcohol use. That package alone could prevent somewhere between 20% and 40% of all cancer cases.
And internationally, vaccination plays a huge role, too.
Absolutely massive. Vaccinating against cancer-causing infections like HPV, human papillomavirus, and hepatitis B. In some lower and middle-income countries, these infections are linked to maybe up to 25% of all cancers. So vaccination is cancer prevention in those contexts. And this isn't new speculative stuff. This is solid, established science.
And yet, despite this overwhelming evidence that prevention is our most powerful tool from a public health perspective, the funding just doesn't seem to match. You look at the U.S. National Cancer Institute budget for, say, fiscal year 2018. Only about 5.7% went to cancer prevention and control. 5.7%. That seems astounding, given prevention could potentially stop half of all cases. Is this just about policy choices favoring expensive treatments, or is there some scientific reason prevention gets so little funding comparatively?
It's overwhelmingly a policy, societal, and, frankly, commercial issue. Developing and selling treatments for existing diseases is incredibly profitable and addresses an immediate, urgent need for sick patients. It gets attention. Prevention, on the other hand, it requires long-term investment in public health infrastructure, education, changing social norms. The results are less visible in the short term. They happen over decades. So the intense focus on developing high-tech, high-cost personalized treatments, while absolutely vital for those who need them, often comes at the opportunity cost of investing robustly in the prevention that could stop people from getting sick in the first place.
Okay, so let's try to wrap up this deep dive. The big picture seems to be amazing progress is happening through very sophisticated, personalized medicine, these vaccines, smart cells, targeted drugs. But the single biggest lever we have, the one that could prevent immense suffering altogether, that's prevention.
Yes. And the goal for oncology itself is definitely shifting. It's moving away from chasing that single, probably unattainable, universal cure. The focus now is much more on turning many cancers into chronic, manageable conditions like diabetes or heart disease, or achieving really long-term, durable remission through these smart, personalized approaches, and of course, preventing as many as possible.
Which brings us right back to that powerful link between our biology and our choices, our environment. You mentioned that finding about high-risk women with a high genetic risk for breast cancer. If they adopted a healthy lifestyle, maintained a low weight, didn't drink or smoke, avoided certain hormone therapies, they actually brought their risk down to the same level as an average risk woman. So if genetics isn't necessarily destiny, and we know these highly effective prevention strategies exist, why isn't this knowledge and the means to act on it available and accessible to everyone?
And that really is the crucial question, isn't it? If we have this knowledge, what systems, what policies, what societal changes do we need to make sure that everyone, regardless of their background, their income, where they live, can actually access and benefit from these powerful prevention strategies? Because, prevention that only reaches the well-off or the well-informed, well, that isn't really public health success. It's just good fortune for a select few.
Now,
making it universal, that's the challenge.
a profound challenge indeed. And perhaps the most important one if we truly want to conquer cancer in the broadest sense. Something for all of us to think about.
Don't forget to like and subscribe for the next episode on While We Were Distracted.